All right, so we're going to look at different methods of saving. So I'm just going to go through some different kinds and maybe some examples with them, and that'll be it. So a savings account. Um, you probably already have one, to be honest. Most people have a checking account and a savings account. So it's a deposit account, usually at a bank or a financial institution, that you earn interest on. Uh, Risk-wise, there's usually not a risk, and they're usually insured for up to $250,000. So some strengths here is that there's high flexibility. You can choose what to put in, you can choose what to take out. Normally, depends on the bank that you're at. Maybe they put a limit on the number of withdrawals you're allowed. Maybe they don't. Um, and sometimes they might say you have to have a minimum amount in there or you'll have some fees, but sometimes they don't. Just depends. You just have to do your research if you're looking for a savings account. So here's an example. So Violet deposits $4,520 in a savings account bearing 1.45% interest compounded annually. If she doesn't add to or withdraw any of that money, how much will be in the account after 3 years? So we'll use that same formula from before. I'll just rewrite it here. And then I'll plug in what we know. So I want to know the final amount. I know I initially put in the 4520. My rate is 0.0145. It's compounded annually, so my n is actually 1. And then 1 times, 3 years. So I don't really need the ones there, but I always like to plug it into the formula just so I know where all my numbers are going. So let's plug it in a calculator and see what we get. So I get a final amount of, sorry, I'm still plugging in my calculator, $4,719.48. Right. So nothing new there. Here's something that might be new. So certificates of deposit, so maybe you've heard them called CDs. This is a different kind of savings. So it's an investment that lasts for a fixed period of time, and then it's agreed to when the money is invested into the CD. So you could go say, hey, I'm going to buy a $50 CD, and I want one that's 5 years, 20 years, whatever the case may be. It says 6 months to 5 years. I guess it just depends. But money from the CD can't be withdrawn without penalty until that time period is up. So if you put in $50 into a CD and it said 5 years, you have to wait until that 5th year to be able to pull it out, and then you can see what interest had been earned on that. And then you can't add money to it. You'd have to buy a new one. So they're kind of like the savings in the fact that they're insured. So the risk isn't as, it's not a high risk. There is a better interest rate than savings accounts. The downside is you can't pull money out whenever you want without there being a fee, unless you've waited the entire time. So, all right, let's see. We've got $10,000 in a CD that yields 2.71% compounded semi-annually for 5 years. How much is a CD worth after 5 years? Actually, we can use the same formula. So we have an initial amount that had an interest. Let's see, compounded semi-annually, so that's n equals 2. And then for 5 years. So let's plug this into a calculator and see. I get $11,139.54. Okay. Something called a money market account. So similar to a savings account, except the number of transactions is generally limited to 6 each month. Money market accounts typically have a minimum balance that must be maintained, and if it drops below, then there might be a penalty. Let's see, they offer the flexibility of checks and ATM cards. And then the interest rate on money market accounts typically higher than the interest rate on a savings account. So, all right, let's see, we open a money market account, we deposit an amount, it has an interest, compounded monthly, so N is 12. There's no other transactions. How much will there be in 4 years? So, okay, initially 2,500, a rate of 0.176 monthly, and then for 4 years. So let's plug this in. So I get 2,682 and 20 cents. Okay. There's something called a return on investment, right? So we want to compare the profitability of different investments. And we could look at the return on investment as that measure of comparability. So also known as ROI. And it's just the difference between the initial investment, P, or that principal amount, and then the final value. And it's expressed as a percentage. So we would divide it out of the number we had used as the principal. So let's look at this. The amount of $13,000 is invested in a savings account. After 10 years, the account has $15,250. Find the return on investment for this account. So the ROI is going to be that future value. So 15,250 minus the principal amount. So 13,000. And then out of that 13,000 we originally put in. So let's calculate that. So I get 2,250 out of 13,000, which gives me 0.173, and then it keeps going. I'm going to stop it at 3 decimals. It doesn't tell me where to stop, but I'm just going to 3, which is about 17.3%. I'm going to turn that back into a percent there. All right. Okay, this is a big formula here. So annuities as savings. So in compound interest, we talk about the future value of a single deposit. But what if you're making regular payments each month to an account? So this formula here helps us with that. So the payment, or the future value, is the payment you're making each month, and then times 1 plus rate over number times compounded to the nt minus 1 all over r over n. All right? So let's use the formula one time just because. And then I can show you in, I think Excel will do it for us. And I think, yeah, we're going to use the formula for these two things. And then I'll show you how to also do it in Excel. So Jill has an account that bears 3.75% interest compounded monthly. She decides to deposit $250 each month at the end of the compounding period into this account. What's the future value after 8 years? So, all right, with this formula, the future value is the payment times, if I draw a straight line, 1 plus the rate over compounded monthly. We want 8 years over the rate over compounding. So I'm going to go back to Desmos and plug this in. All right, so we have 250 out front, and then 1 plus 0.0375 over 12. Oh. Raised to the 12 times 8. We can just throw that in parentheses. 12 times 8. And then minus 1 over 0.0375 over 12. All right. So 27,938. 20. I'm going to go back here and write that down. 27,000. I already forgot. 938.20. 938.20. Okay. I am going to show you how to do it in Excel as well. I'm going to go in Google Sheets, but same thing. All right, so what I did here is I wrote the number that we needed, and I say that, but I didn't write the 0.20. 27,000. 938.20. Okay. So go into a new cell, and we want to tell it to do a formula. And so it's built in for us, that whole formula, so we don't have to do that every time or plug it in Desmos. So if we want to use a formula, we're going to put equals, and then we want to know the future value. So if I just type in FV, then it pops up. Now for me, it shows me what I need. I can't remember if on Excel if it does or not. I feel like it should. I'll go back and write on the notes so that you have it in case for whatever reason it doesn't. So it says rate. So the only difference here, we want to put in the rate of 0.0375. But the way this future value formula is working is we want the monthly. So this is an annual rate. So we need to divide it by 12. So no matter what, that rate is going to get divided by 12. The number of periods. So for how many months is this happening? Well, it's happening every month for 8 years. So we can say, hey, just do 12 times 8. And it will do that math for us. The payment amount. Well, we're told we're doing 250. And then it says present value. So we're assuming, unless it says otherwise, that the present value is 0. Then I can hit enter, and then I hope I get that same number. Yeah, so it's going to give out a negative number because the way this formula is working is it's saying that you are making payments. So if you are making payments, you are in the negatives. This is not saying this is not acting as the account itself. It's saying all right, this is how much money. Well, I guess I shouldn't say that because it's getting all the interest. It's okay that this is a negative number. We'll just take the absolute value of it. Because do you see it's the same number, just a difference of a negative? It's okay. All right. We can do the same thing with this other scenario. It's backwards in a sense. So instead of saying all right, I'm saving up for this house. I know what I want my down payment to be, how much am I going to have to put in? Instead of using this whole formula here, it's just a rearrangement of this one, right? We can use Excel as well. I'm going to plug it in this formula because I'm an algebra person and I love it. So I'm going to do that for this scenario. And then I'll plug it in Excel. And I said I was going to put the formulas here. So final value in Excel or Google Sheets. So you want to open a cell, do equals. And if you don't like it having a negative value, you can do negative FV. Or you can do just regular FV, that's fine. So you'll do the rate, and I'm going to put rate over 12. And I'm actually going to put over N because This one was monthly. So I'm going to put R over N. And then what was the next thing I wanted? I already forgot. Number of periods, payment. Okay. Number of periods, which I really should say that's just N times T. And then you put payment amount, and then I'll put present value, and we can close the parenthesis, and usually that's 0. All right. Let's see here. So we want to save for a car that we're going to get in 3 years. We need this amount for the purchase. And if we're doing an ordinary annuity that yields this interest compounded monthly, how much do we need to deposit? So, all right, the future value, we want it to be the $35,500 times R over N, so 0.0425. N, it's monthly, so 12 all over 1 plus 0.0425 over 12 to the NT, so 12, and then 3 years, and then minus 1. So that's the formula. Let's do it in Excel. So I know it's going to be equals PMT for payment. And then after that, I'll fill that out. All right, so I should go into a new one. Put here equals P, and it might show up for me. PMT. Oops, maybe not. PMT. Rate, number of periods, present value, future value. Okay, so our rate was 0.0425, and we're going to still divide that by 12. And the number of periods is 12 times 3, which if you want to go ahead and write 36, you can. And then the present value, and we're going to assume 0. And then the future value, we want 35,500. So our payment, or what we should be throwing into this account, is $926.32. $936.22. So it was the rate. I'll just do the same notation. R over N. N times T. We'll do present value, which is typically 0. And then we'll put future value. And then it'll calculate for you. And all right, that is all for the different types of savings that we talk about in this class. If you have any questions, let me know.